Good morning, bio. It's good to see you guys. All right, so today you're going to probably use this video to help you out a little bit. Sorry I'm not there. But this is pretty much like if we were having regular class. I'm going to ask you to pause me every once in a while. When I say pause me, you're going to pause, go off and do what I asked you to do, and then you'll come back and you'll press play, and then I'll give you the next set of instructions. So that pausing moment, right, is going to be important because if you just watch this all the way through, you've got to remember like everything you have to do, and you might as well get it in smaller chunks. All right. So remember that today you do have a quiz. All right. So you can use your notes on your quiz. All right. But do remember that these quizzes are only able to be taken on your school devices. And if you pop up another tab, your quiz is going to get submitted probably with a grade you're not going to be happy with. So open up the quiz. You can use your handwritten notes, take your quiz, and then you can open up other tabs and take care of the materials you need to do for the day. All right. For purposes of making sure that you get through as much as possible today, I'm actually going to go ahead and move part 2 down to the last part of today. And we're going to do part 1, part 3, then part 2. It'll just make a little bit more sense for you to at least get started on this activity and get all the information down while I'm available to possibly answer some questions instead of doing your CK12 reading, which you can pretty much do at home for homework if you need to. All right, so let's get started. Your biomolecule quiz shouldn't take you more than 20 minutes. It's worth 20 points. Do your best job. And I'm going to say pause. Pause me now and take the quiz. Welcome back. I'm glad you got your quiz taken. Let's go ahead and get started with what you're going to be working on today. So open up part 3, factors affecting enzymes. Open up part 3, factors affecting enzymes. And then you'll click on W6D2 and then also open up W6D2 Enzyme Lab data. Once you've opened both of those documents, please go ahead and go to W6D2 Factors Affecting. That's the document. Open the document and let's read along together. So, objective. Your objective is to study several factors that affect the activity of enzymes. Now, here's some background information. I'm going to have you stop and pause and look at this background information. Only spend about 5 or 10 minutes looking at it. Do not spend more time or you will fall behind. All right, welcome back. So, hydrogen peroxide, we use this on Monday or Tuesday with our livers. When we put the hydrogen peroxide on there, which the liver is the catalase, it ended up producing water and oxygen. Now remember, water at room temperature is mostly a liquid. Oxygen, however, is a gas. So a catalyst, reminding you guys, a catalyst is an enzyme. It's present in most cells and found in high concentrations in the liver. And because it's found in such high concentrations in the liver, when we started this activity, it actually went too quick to record data. So, once you look at what we're doing for materials, you're going to watch this demo video that was made in an Ed puzzle or made into an Ed puzzle. You're going to create a list of procedures from the lab while you watch. So you'll put here like step 1, take the catalyst and put it in the test tube, whatever it might be. Okay. So you'll list out your procedures and then you'll move forward, but you got to watch the video first. There are some embedded questions just to help you think about what's going on in the video as you're watching. But I'm going to have you pause and watch the video. All right, welcome back. Good job. You got all your procedures written down and you got to watch the video. I know, it's a bummer. COVID's kind of screwed all this up. But we have already got all of the data made up for you. So you're going to use the pre-made Google Sheet, which you should have already opened, to analyze the data collected from this lab. We actually used results from last year. Follow instructions that I am going to help you through to build your 2 graphs so that you can insert them in your graph below. So I'm going to go ahead and jump over to the W6D2 enzyme lab data. All right, whenever you look at data, the very first thing you need to do is look at the table and think to yourself, what is this data telling me? You might not be able to see trends or understand everything just from the numbers, but look in general. What do you see? Well, table 1 is the oxygen produced, the gas bubbles from the video, using liver catalysts at a very high pH. At varying pHs, not very high. So I have milliliters of oxygen produced, and then I have my different pHs. So that 7 is a different pH, 3 is a different pH, and 10 is a different pH. 7 is roughly where you would find water. 3 is a pretty strong acid. 10, pretty strong base. So, time in seconds, we've got 0, 30, 60, like in the video, and it goes up to 300. Now, I'm not sure why this is highlighted yet, but I'll get there. It looks like we need to find the rate of the reaction. That'll be interesting, but I think I have an idea how we can get the rate of reaction. Now, table 2 seems to have very little information to us, except for rate or slopes of a reaction of hydrogen peroxide with liver catalysts at varying pH. So it looks like we're going to have another graph that's going to look at the rates and slopes. And that'd be the pH of, I don't think it should be a pH of 2. The pH was 3, so let's change that. And 7 and 10. All right, so let's go back up to table 1 and let's start looking at how we might need to graph these things. Okie dokie. Well, looking at this data and remembering back to the end of the video, when bubbles stopped producing, that meant that there was probably no more substrate, and that meant that the enzyme was no longer working. So would we really need that data in our graphs? Well, the answer is no. We probably don't. So I want you to take a look at the 7 pH. Where does it look like it stops producing bubbles? Maybe around the 240 minute or 240 second mark. I want you to look at pH 3 and pH 10 and kind of decide for yourself where it might stop. Highlight it. in green. All right. Probably the majority of you picked something like the 66, 68, 69, or just the 68, 69. Or you may have just picked this 41 bunch here. Well, to keep my graph nice and consistent, I'm going to go ahead and call these ones the data I don't need to worry about because it probably means my substrate's gone. So let's go ahead then and graph the data from the 0 to 210 seconds. Remember, that will be on our x-axis. And then we're going to come over and we're going to grab the 7 pH, the 3 pH, and the 10 pH. So this should result in 3 lines being on our graph. Now, if you don't remember, once you've highlighted it, you go up to Insert, Chart. And that will take the data that we highlighted and create a graph of it. Now, wait a second. Remembering back to when we talked about graphs at the beginning of the year, bar graphs look at categories of information. Are we looking at a category of information? That's right. The answer is no. So we're going to have to change this to be a time, looking at time, changes over time. And that type of graph is a line graph. So let's put our graph over here so we can still see our data. And if you happen to click off your graph, you can still edit it. You just need to go up to the 3 little dots, or the snowman as I call it, and you'll hit Edit Chart. Okay, so we said we needed to change our chart type. And I think the chart type that we need is a line graph. That works. So let's look at our data and make sure that our lines make sense. So this blue line shows a point here, and it was about 50, right? And it's probably about maybe 30. Oh, yeah, that's right. 50, 30 is the 7. So this blue line is our pH of 7. We should probably fix that in our legend. So we're going to go pH. Oh, remember, it's little p, big H, 7. Alrighty then. Now that we fixed that one, let's look at the red line. At 50 seconds, 50 seconds isn't on there. Let's see. There's a dot. So I'd say that's maybe like 60 seconds. And it's probably somewhere around 20. So let's go over to our data. And at 60, we had pH of 7 was at 80. And of course, that's the blue line. Then we have 23 and we have 11. Well, we know this line is the middle here. So it's got to be a pH of 3. So go up and change your red line in the legend. Double click on it to be little p, big H. Little p, big H, 3. And now we know our yellow line then has to be, double click on the little yellow guy, and that one has to be a pH of 10. All right, there's a couple parts of our graph that we haven't done anything with that probably would be important to maybe think about changing. And that is labeling our axes, because this table 1 oxygen produced, that's not an axis of 50, 100, 150. that represents time. So you need to change. Remember, if you need to change your vertical axes, you can change them in here. You can customize them. That's it. Charts and axis titles. So then you can change them, as well as the chart title, because the chart title currently is not a good title. Now that's what you're doing on your own when you put your graphs into the document. I'm going to help you with the more technical stuff, and that is we need to find the line of best fit, the trend line, and then we need to get the equation for those lines. So if you click on the blue line, all right, that's going to help bring up series. We're going to want to find a trend line for all series. So we're going to go ahead and say apply to all series. And then I'm going to scroll down here and click trend line. Now that put trend lines in. You can see the light blue one here, and there's a light pink and a light yellow. But that's not all that I need, okay? I also need to see the equation. So I'm going to go down to the label, and I'm going to say use equation. Now I'm going to click off. What you'll see here is that for pH 7, I have my line of best fit and a equation that is sitting here. Now, yep, I did it. I'm making you go back to good old math class. Y equals mx plus b. B is where our y-intercept should be. So about 28 there. Oh, 28 there. And y is whatever y number you put in. And x is whatever seconds you put in. But the real important one here is the number attached to the x. That's your rate. So 1.02 times x. 1.02 is the rate. Okay, so once you find your M, which is your rate of reaction, you're going to come over here and you're going to put your rate of reaction in here. And that should be milliliters per second. Don't forget to use units are important when you are doing your data in written form. Okay, the units are attached right here in our chart. So here we're going to put 1.02. And here we're going to put 0.291. And then here we're going to put 0.0, nope, I'm reading that wrong. 0.176. So that is the rate of reaction for our pH of 7, pH of 3, and our pH of 10. Now it's time to make graph 2. Don't forget, you have to come back and you have to fix the axes and the titles. Okay? But for here, right, it didn't bring in our rate of reaction for 3. So let's go ahead and make sure that we put it in there. And so that's 0.291. Okay, now we have new data. And this data is telling us the rate or slope of the reaction of hydrogen peroxide with liver catalyst at varying pH levels. Those varying pH levels were 3, 7, and 10. Let's take a look at what this data might look like. So remember, highlight your data, come up, hit Insert, Chart, And it always wants to come up with a column chart. We know that's not right. So let's put in our lines. All right. For some reason, this line chart wants to graph the pH over here. And we don't want that. So let's see. We've got to change our axes. So 22, 23, and 24, right, of A do not need to be there. So I'm gonna, I made those no. Do I have those as my x-axis? No, this is not right at all. Let's restart. Delete chart. Okay. So, grab your data, go up to Insert, Chart. Let's see. Our x-axis is the A, 22 through 24. And our series are just B, right? We just want the B, B22 to B24. And I didn't highlight labels. So I'm just gonna, I can't get rid of it, but I'm not worried about it right now. Okay. So that changed us there. So that should help our line graph look right. Okay. Now that we have our line graph looking right, because the 7 had a really higher rate of reaction than our 3 or our 10. All right. So what we'll do is we are now going to run similar to a line of regression where we did the line of best fit, but this time we're going to use a line of best fit that is actually going to look at the parabola. So under series, okay, which is the rate of reaction, you're going to want to come and put a trend line in. Now, last time we did a linear trend line, but this time we are going to do a polynomial trend line. And that'll help us see how the rate of reaction is occurring. And if you want, you can throw the equation in there. Never hurts to see the equation, right? All right, so this is our rate of reaction, and we have our graph here. The very tip-top point here is where our reaction or our enzyme is going to work the best. And it looks like it's somewhere between 7 and maybe 6.5, somewhere in there, right? Now that's just looking at the statistics, the analysis portion. You're going to want to fix your titles and your axes here, which this one actually turned out not bad at all, okay? And then you're going to want to, I believe, copy and paste, right? Copy chart, and then paste it into your worksheet. So pause and do that. Once you've completed, or welcome back, once you complete those two things and you now have two charts here, you're going to use, or two graphs here, you're going to use those graphs to answer the conclusion data. Now, if you noticed, I said I'm making this assignment due Friday night, so you have plenty of time to process the questions and answer them thoughtfully. Please use all the vocab that you can think of, like enzymes, substrate, activation site. Let's see. Rate of reaction, right? Optimal range of the reaction. And you're going to use all those words to help you in answering these conclusion questions. All right. If you have questions, we have office hours today from 2:10 to 3, on Friday from 2:10 to 3. You could pop into office hours and ask me a specific question and say, hey, Ms. Strong, on question 2, I was struggling with this. Can you help me? I'll be there. You do need to email me, though, just to remind me to make sure that I'm there to meet you in the Zoom room. Remember, there's a topic in Google Classroom titled Office Hours, and you can see me there. All right, I hope this helps you navigate through part 1, your quiz, part 2, your factors affecting enzyme lab activity. Remember, I switched them up. And then the last thing, which hopefully should now just be maybe a homework assignment for 15 minutes, right? Shouldn't take you much longer, is a reading on CK12 about enzymes. Don't forget, at the top of the CK12 page, after you've done your practice problems, there will be a yellow or an orange, depending on the color scheme of your screen, yellow or orange button that says turn in. If you don't submit that, you won't have a grade for your CK.